Good morning.
Morning.
Good morning, sir.
Good morning, sir.
Good morning.
Good morning, sir.
I think 37 students are there. So let's start. Okay. Today we'll discuss about contents of your syllabus and how we will proceed, and followed by how to write assignments, how to submit it, and how it will get evaluated. Yeah. Mute mic. Okay. Okay. Is screen visible?
Yes, sir.
Okay.
Yes, sir.
So solid modeling and drafting. Okay. Now this is new subject introduced to you. Okay, because in previous years this subject was not there. It was just for practical purpose. No theory was attached with this subject. Now with this subject we have attached the theory also. Okay, so we will see one by one what are the contents of this syllabus. Okay, so pattern, as you know the pattern. So 3 hours per week, total credit 3, practical 2 hours per week, credit 1. Examination pattern will be 30 marks, in SEM and end SEM 70 marks. Practical will be conducted for the 50 marks. Now, if the situation remains same, in that case, it will be a big challenge to conduct the practical online. That means we have to show you the various softwares, and regarding your practical exam, don't know how we are going to conduct it. But for that purpose, you should be regular in submitting assignments, because if it is difficult to conduct this practical exam, in that case we have to evaluate you on the basis of how we evaluate you on a continuous basis. Okay. So side by side, uh, in one lecture we will see the practical also, because this is moreover software based subject, and how software operates is a theory. Behind that software we will also cover that theory, so theoretical part as well as the practical part. So these two things go in hand in hand. These are the 6 units. First is 3D modeling and weaving, then geometric modeling, solid modeling, computer graphics, CAD data exchange and standards, CAD customization and automation. Okay, I think all these words are new to you. Okay, so you have gone through the 2D drafting, that is AutoCAD. Now we are going one step ahead, that is a 3D. And with this 3D attached, this topic is based on the entirely based on the CAD requirement of the CAD, computer aided design. Okay, so this is base of your mechanical engineering. Okay, if you want to be in a design field, in that case this CAD is must, that is computer aided design, but with the help of computer. So we have to understand the things. Okay, we will see unit one by one. Okay, what we are going to learn in a 3D modeling and viewing, that is product life cycle and CAD tools. Means product life cycle means whenever we launch any product, or whenever there is a product which comes into market, how it propagates. Okay, what are the different phases of that product from starting till the death of that product, means that which is not used in a market. Okay, so some products are that they start, they reach up to a peak, then their utilization or sales gradually decreases, and one time comes that it is will not be in a, say, in a market. So for example, have you heard about the pager? Okay, before mobile it was a pager. On that pager you will get the message. That means SMS facility is only available. Nowadays we get a SMS or WhatsApp message on our mobiles. Before that there was a small devices. On that device we can receive the message. For that purpose we have to call a call center. From that call center we have to provide the number and the message. That call center writes the message to that particular device. So it will be a long process, and so that whoever carrying that pager gets the message, short message like SMS. Okay, so this was the a procedure. Now it was a peak before mobile. Once mobile comes in the market, this pager facility is included in the mobile. So pager vanishes from the market, so it will not be used in the market. So how the cycle of development of a pager, then it reaches to the peak, and then it's decline and uh, vanish from the market. This is called as the product's life cycle. Now during this product life cycle we are using some CAD tools. Now this product life cycle may be in terms of marketing, maybe in terms of designing, or we can say that product life cycle inside the industry, how that product is designed. Okay, from where the requirement comes, what are the different phases of designing, so how that product is get designed, how that product is get manufactured. So that cycle also we have to consider during this development of that product. Okay, we use a computer. The computer means a various softwares of a mechanical engineering. Okay, so that softwares, how this softwares helps to develop the product is a computer aided design. So we will combine, or we will see the effect of a CAD tools on the product life cycle. That means how the product gets developed faster using the CAD tools. Now what are the different features of a CAD, then what are the requirements or what are the applications we will see. Then 3D modeling approaches, that means whenever we want to generate a 3D model, we have created a 2D sketch, engineering graphics. Okay, we have one practical on a AutoCAD. So what we are going to do in that practicals, or what we have done, that you are drawing something with the help of AutoCAD. Different commands we have used, that is purely 2D. Maybe you have gone through the some 3D, but that is a very primitive in case of a AutoCAD. So we will learn a different high-end softwares which include a 3D modeling. So what are the how these 3D modeling softwares are developed? That means what is the basic behind that a particular software. So these these are the primitives. Primitives means solid things which can be defined with the help of, say, mathematical equation like cube, sphere, okay, then cylinder. These are the primitives which can be defined with the help of, say, mathematical equations. So solid modeling using these primitives is small blocks of for mathematical equations. Then various features like hole, okay, reeb, okay, then various other features are there which can be used for the generation of model. Then one more approach. Recording is on or off?
Sir, it is on.
On,
Okay.
sir.
I think. Okay. Are you able to see the screen?
Yes, sir.
Okay.
Yes, sir.
Okay. So sketching means you have drawn the sketch in a AutoCAD. Now this sketch can be used for the development of a solid. We will see this, what are the different modeling approach in details. Types of geometric models, then modeling strategies, that is top down approach or bottom up approach. Okay. Now after this, there are facilities which will help, web based facilities which will help us to visualize the models. Okay. Now why this facility is used? Because these softwares are high end software. So whatever the file size which we are creating is a bigger. Okay. Now it is not possible to visualize that particular solid model or that particular product which you develop using the solid modeling software. Okay. In that case, it is difficult to, we can take the screenshot or you can generate the drawings, but for visualization purpose, okay, solid modeling software have a facility to revolve, rotate. So similar facility you will get model viewing, VRML, web based viewing, where actual solid model will not be there. Will be the image of that software which can be rotated and which can be visualized without the basic software, because these softwares are very costly and it is not possible to have a uh, software at your end to just the view the model or assembly or a different product. So this will consist of a unit number one. If you look at the unit number one, this is total a theoretical one. Okay, more you uh, read, more you will understand. Okay, so basic things are there nowadays. Every day there are many changes in the CAD, how these CADs are used in the industry, different approaches are there. So every day different things are coming up, because every year these softwares are coming with a newer version. There are many changes, many small changes or many major changes in the particular software. That's why they come with the newer version. So you have to go to different websites of these softwares and can read what are the new things in a new release. And they also provide some case studies where you can see the utilization of that particular software for development of a particular product. From that you will understand what are the capabilities of that particular software. At present, what we can have is that uh, we can learn the software in a, say, for even if we have, say, 14-15 practicals, that means around 30 hours. In that 30 hours we have to learn entire software, which is not possible. Okay. So whatever the we are getting, we can be familiar with that particular software only. Okay. Now geometric modeling. What happens that these are the softwares, and we can see that these softwares have the uh, very large size. Okay. and whatever the file generated, it has a say minimum 4 MB, 5 MB file, or it may be even a greater file depending upon what are the contents. Now, say for example, this is the curve. Okay, this curve can be drawn in a simple paintbrush. Okay, same curve can be drawn in a high-end software, or same curve can be drawn in your AutoCAD. Okay, now difference between drawing a curve in a paintbrush and different software is that in a paintbrush we are creating images only. That means we are changing the color of the pixel, okay, along that particular path. Okay, if you try to zoom that particular line or such curve, you will find that the color of that particular pixels are getting changed, nothing more than that. So saving that particular file as an image file will be consist of the color combination of different pixels. So it will save the pixel properties as uh, a file. But when it comes as a software, mathematical base is required. Now in high-end software or even in AutoCAD, these curves are saved as a mathematical equations. Okay, so there are two different things. Okay, analytical curves and synthetic curves. Similarly, analytical surface and synthetic surface. Similarly for the solids also. So what happens that up till now we have seen the equation of a line. Say for example, y is equal to mx plus c. Now this line has a length is infinity. Okay, minus infinity to a plus infinity. But whenever we want to use this line in terms of a software, we don't want an infinity line. We want a particular piece of line, or that means a segment only. So style of representing the curve in a software will be a different one. Okay, it is not possible to define the line in terms of say y is equal to mx plus c. Okay, so that curves are represented with the help of a parametric equation. So we will see parametric equations. Up till now you have not heard about this parametric equation as far as your course is concerned. Now similarly we will see the representation of surface and reverse engineering. Okay, we know that reverse engineering, one product is available in the market, okay, we can copy that product and then make a modification, and then we can have the reverse engineering. But means that we have first we have the product and then we will go for the modeling of that product. It may happen that with some soft material, okay, say clay or or any other raw material, okay, or with the help of powder, a powder of particular synthetic powder, which can be on heated get molded, and we can give a particular shape. We can create some product with that particular shape, and once we have that our own product and we want to create now, we can give particular shape to that product. Okay, say by removing material or adding material or a clay model, where we can go for the entire clay model and we can give a shape as per requirement. And once that particular product is ready, now we want to convert that product into a solid model, because with once we create that solid model, it can be used for the various purposes which we also see. So reverse engineering not does not mean exactly the copy of product available in the market. We can have our own product with but manufactured with different material, or maybe regular material, and then now we want to convert that product into a say software base. Its all definitions will be in a software, or we want to create a solid models out of that. That is a reverse engineering. Okay, a bigger unit or a small bits are unit in a solid modeling. That how solids are model are represented. Techniques of solid modeling, Euler's equation. That means it consists of say surface, then edges and points. There is one we can have a particular equation. Once that equation is satisfied, that means this solid is a valid solid. Okay, it means it does not have a say some opening, because this is required, and we will see why this equation is important. Then a boundary representation, how this solids can be represented, or constructive solid geometry, how the solid can be modeled with the constructive solid model. Once we have the solid model with us, we can find out the mass property. Okay, what will be the volume, what will be the weight, what will be the surface area of that particular product or that particular component. A mass property, say in the terms of volume. Okay, it can give help us to find out the what will be the space required for that particular product. Okay, then mass property will give you approximate costing for the material. Okay, similarly surface area will help us to find out the what is the surface area. Now depending upon the surface area, if we want to paint that particular product, so how much quantity of paint will be required, or what will be the costing of that particular area to be printed. This will help us to find out the once we create a solid model, mass properties can be generated. Now introduction to assembly modeling. Okay, now here we talk about the a single model. Okay, single component. Once components are ready, we can assemble this all this component in assembly modeling. That means 10 parts, 20 parts. Okay, that we will define the relation with a part with each other. Okay, and then we can have a solid model, or a particular product consists of different solid models. Design for manufacturing. Okay, now when we are developing one particular product, okay, and we also have to see that this product can be manufactured. Say if you are designing a particular part which consists of a say a cube, and inside that cube we have some spherical hole. Okay, now if we design like that, it will be difficult for us to manufacture that sphere inside that particular cubical shape. So no use of designing a such component, which will be difficult to manufacture, or manufacturing cost is very much large. So in such cases we have to see the what are the different parameters which we have to consider for the design of for manufacturing. Similarly, for design for ease means how easily that particular uh, can be manufactured, assembly and disassembly. That means once we assemble, then disassembly means that how we can one by one disassemble that particular components. Now in various product brochures, okay, you can see this feature disassembly. One sec. Where we see the exploded view. Now this exploded view help us to see that how this component can be assembled, one component. Then if you want to disassemble that component and again assemble, so we need to remember the sequence. Instead of remembering the sequence, we can refer the product guide or particular brochure. On that brochure, one diagram is given. Instead of entire assembly, various components on one another is given. Okay, that means after looking at that, we can visualize that how this product can be assembled. design for safety. Okay, when we design a particular product, that should be a safe to utilize, or it should not harm any particular person nearby. Okay. Various parameters are there, and all these things are a theoretical one. Okay. Now computer graphics. Okay. In computer graphics, we will learn a geometric transformation, then various coordinate system, that is model coordinate system, working coordinate system, screen coordinate system, or a global coordinate system. There are different coordinate systems are used when you are going for the construction of particular a model. Then geometric projection of geometric models, that means orthographic projection and perspective projections. Then design and engineering application of this transformation, or say coordinate system and the projection. Now we will see one by geometric transformation. Means that you have used the AutoCAD. Now in AutoCAD you also use the modify command, say move, copy, okay, then rotate, trim, scale. These are the various commands which under modify command which we have used. Now when you give a particular command, say move command, what happens behind the your screen? Means that your user interface. Now how exactly this is carried out? Because if you go give move command to a line, what happens that you can pick that line, and then first reference point and second reference point, first point and second point. So what happens that the line moves. Now we know that we save the line in terms of a mathematical equations. So whenever we move the line, that naturally the mathematical equation is going to change. So how these mathematical equations are changing and how these mathematical equations are saved, this is geometric transformations. So this is a numerical things are there in a geometric transformations, and this is based on the numerical equation. Now coordinate system, model coordinate system, working coordinate system, and screen coordinate system. Now you are looking at this screen. Okay, generally this is upper left corner is many times it is a 0 0. If you go for the C programming language and want to draw a particular graphics in C programming, it will give this as a 0 0. This is positive X and this is positive Y. Many cases nowadays it is used as a this as a lower left corner used as a screen 0 0. Okay, now with respect to this screen 0 0, you are defining a different things. Okay, because what happens that you can change the resolution of your display, maybe 800 by 600, 1200 by 900, and so on. So what happens that whenever you resolve, that means you are changing the x-axis dimension and a y-axis pixel sizes. Okay, now with respect to this, our different windows of our softwares are defined. Okay, now whenever, even if you are looking at your screen now, there are different windows are available. In one window you are seeing this presentation, something on left hand side, something is right hand side, something is on the bottom. We are defined by the some rectangles. Now these are the areas which are defined. Now even if you are changing the display size, they are automatically again set. That means that this screen coordinate system and the mapping of that particular rectangular window is predefined. Okay, so with respect to screen system, we have to define our working area of a particular software. Software consists of different windows. Some pull down menus are there, some side guidelines are there, on left hand side, right hand side, bottom. Generally, we have the command prompt. So all these areas we have to define with respect to a screen. Okay, and we are have some working area in that particular area which we can work. That is working coordinate system. Say in a case of AutoCAD, you can see the a working area defined by X and Y. Some commands are there on the left hand side, some on a top ribbon. On a bottom ribbon, you will get the say some facilities like command prompt. You can increase or decrease the number of lines on a command prompt. Some more features are there. So bottom ribbon is different, okay, which indicate the your Windows facility. Okay, the working coordinate system. Now, once we are defining a working coordinate system, then what is model coordinate system? Okay, whenever we want to create a model, okay, and it is whenever it is a 3D model, in that case, we cannot always work with the your working coordinate system. Okay, now even if we are saying that 3D modeling, from this stage we always talk about in terms of a 3D modeling. Okay, but uh, with the help of computer you can work in a 2D environment only. Okay, even if you are creating a 3D models, definition will be in terms of a 3D, but you have to always work in a 2D environment. Okay, because your input device is mouse. Okay, generally which we are using, or a keyboard, and the display device is monitor. The both things are a 2D. You cannot work in a 3D. Okay, so we are creating a 3D model, but we always have to work in a 2D environment. So we have to shift our working coordinate system on the model, and with the help of that model we are defining a system that is called as a model coordinate system. So model, a particular model has particular 0 point, and then with respect to that we are defining one coordinate system which will help us to create different features on that particular model. Okay, we'll see also that we can see these things in a better way in whenever we are using a particular software. Then projections. Now once we define a particular solid model, now it is easy to generate the your drawings. Yet we have created drawings that side, front view, side view, top view, bottom view, left hand side, right hand side, back view. Different views we can have for a particular a component. Now once we create a solid model, no need to again go on drawing the different views. In case of a say with again with high-end software you are drawing a support or you are creating some 3D model and using AutoCAD to draw the 2D drawings of that particular model. It's not required. Once 3D model is ready, you can generate the its orthographic projection. That means a different views. Okay, similarly perspective projection is that orthographics we are seeing that rays are parallel to your a particular plane, whereas prospective projection is from one point we are looking at the particular a model. This is generally used in a whenever we are developing a games. Okay, this is orthographic projection is purely engineering aspect. Okay, we cannot see the models or product in terms of our prospective projections. We have to always look at it as a orthographic projections. Okay, design and engineering applications of this, we will see various things with respect to a particular software. So we'll start our things with the geometric transformations. Okay, CAD data exchange and standards. Okay, CAD data exchange, data quality requirement, multi-body dynamics, and CAD geometry cleanup. Okay. Now what happens that it is not possible to have a design cycle, okay, in a entirely in a one software. Okay, some softwares are strong in a solid modeling, some softwares are strong in a analysis, some softwares are strong in a multi-body dynamics and a motion simulation. So different softwares are there which are have their own advantages or own capacities which are utilized by the industry. So entire things are not carried, or entire uh, CAD cycle is not carried with the help of a single software. So we had to use a different software. For say modeling, we can use your CATIA, then ProE, then solid modeling software. Different solid modeling softwares are there, SolidWorks, okay, and many more softwares are available in the market. Generally, ProE and CATIA are mostly this. Creo is version of your ProE itself. Okay, so these are the softwares which are purely used for the your solid modeling. Now, if you want to perform a say analysis of that analysis means finite element analysis. That means if on that particular component, if we are apply the load, what will be the deflection, or what are the stresses developed in that particular component. Okay, so that is called as a finite element analysis. Or you can have a particular thermal analysis also. That means if some heat source is there and that particular component is in a particular heat source, how the distribution of temperature will be in a your particular component, that can be carried out with the help of ANSYS software. Now, multi-body dynamics, that if you are designing say some different components which are moving components, then how these components move with respect to each other and what are the uh, forces developed because of this motion. Say for example of an engine, we can have different things. One second.
Yeah. Hello, Akshat Arge. Hello, Akshat Arge.
Hello, boys.
Namaskar, Suprabhat.
Hey, Archit Gandu.
Suprabhat.
Hey, Archit Gandu. Gandu.
Vishwajit.
गाईज रेकॉर्डिंग चालू आहे, शांत बसा.
रेकॉर्डिंग चालू आहे.
थोडं इज्जत येत.
CR सरांचा आहे का रे?
Hello. Sorry for the break. Okay. Now we are using a different software. Now, different softwares have their sub-advantages and limitations. Similarly, when we their saving pattern will be different. You cannot open one file of one particular software into another software directly. So we have to have some standards where we can convert that particular say solid modeling file in a neutral database, and then that file can be read by the say analysis software, so that we will study how it is carried out. A quality requirement means that how much quality is required, or what are the things which we have to consider before converting the file and before reading the file. Now, once we bring a particular model in a different software, now we had to clean up, okay, geometry cleanup. That means it happens that entire things will not come, okay, as it is from the say solid model. If model is complicated, in that case we have to clean up some, so that means some openings will be there, something is missing. So in such case, in cases we have to patch up something, or we have to add something, or we have to repair something, so that that geometry or that model can be utilized by the uh, software. Now CAD customization and automation. Okay, customization means if you want to have something, say for example, your nut bolt assembly. Now nut bolt assembly will have some dimensions. Say we define the nut bolt in terms of M8, M10, M12, M6, M5, okay, M20. So there's our facility which will be can be used to customize the things. Means that once you insert the bolt and we define the say this bolt I want in the size of M20, that means in that case all the dimensions will be modified according to M20 requirement. Now, and we can insert that into assembly. Similarly, next time we have to know, do not have to start from the sketch. Same model we can include, and we just change the one particular parameter which will give you a say size M10. Okay, so such things are possible. Customization is carries more things. We'll see what where how can we the customize a particular software. Application programming interface, that a different programming interface are possible with the this software. Now how can we program for a particular software, which this is the feature, we theoretical things we have to, okay, do not have to go in a programming stage, or do if possible in during practical I will show you how the programming can be done, and we can have the a programming interface with the a particular software. Now these are the 6 units. Okay, now with this we have some term work during practical. 2D sketching with geometrical and dimensional constraints. That means in a 3D modeling software we also have to start with the 2Ds. Okay, so what are the different facilities of a 2D sketching, what is geometrical and dimensional constraints, we will see that. Assignment on solid surface modeling for simple mechanical component, that means we have to develop some component, then when we develop some particular component, then we will go for the assembly of that particular component. Assignment on a reverse engineering. Okay, we will have some point cloud data, means that whenever there is a model we can have the photo, or there are different instruments are there which can generate the point cloud data. Means that it captures the coordinates of a different points on that particular a solid model, and with that we can have a generation of a particular solid model. There are different steps. Okay, assembly modeling by importing different components from online resources. Okay, online resources are there where we can get a different components, we can import this component, because it is not possible to develop all the components. If it is a complicated parts, in that case it takes some more time to develop that particular part in a software environment. So instead of that, we can have ready-made components which are available online. We can drag or we can import that component in a software environment and can have a assembly of this one. Okay, a demonstration on CAD customization. That means how customization can be done with introduction to programming language interface. Okay, so how this programming is done and how the softwares are customize. For say your AutoCAD, this is AutoLips was the language which can be used for the customization. Okay, you can write down the program in AutoLips, and once you can execute that program, you will get the ready-made drawing. So you can simple words, you can have a program to write down a program to draw a simple rectangle. In that case, how to draw the rectangle? Okay, by giving either rectangle command or by giving a simple align command 4 times. So what are the input parameters required? Say either two opposite corners dimension sorry coordinates of two opposite corners. This will be the input for that program, and different commands you can write depending upon your input. When you are giving the opposite corners for that program, it will draw the particular rectangle. Similarly, different things depending upon some input parameters. If there is a particular drawing, you can draw that particular line just by giving some particular say dimensions or some particular input values. Say flange, you know that flange consists of a different hole for say your bolting purpose, and one bigger hole at the center for the say pipe where we are applying this particular flange. So these are the 6 different assignments. Okay, now this demonstration importing is possible online, or reverse engineering is possible online, but for that purpose you have to have the software on your computer. So we'll wait for some time, and then afterwards, if it is we see that it is not possible to conduct practicals in a college, in that case we will find out the way how to conduct that. Okay, now any questions?
Hello, sir.
Yes.
Sir, do we need to buy specific textbook for this particular topic, subject, or we will work on this platform only?
At present, there is no textbook available in the market for that this particular syllabus, because it is new syllabus, and official syllabus of this subject is not available on the website. Also, means website of the university. It might happen that within a 1 month some textbook comes. Now, if you see the first 4 topics, these 4 topics are from the B syllabus. Now, for B students, we have one subject that is called as CAD CAM and automation. So your first 4 units are part of that syllabus. Okay, so that books can be utilized, or I will provide some soft copies of some book if I get some soft copies, and in a good format, because some books are available but they are in a image format, so they are difficult to read. If I get a good PDF copy, I can share with you. Otherwise, if we see the reference book, there are quite bigger reference books. Okay, 700, 800 pages, and what you need is introductory part only. So you can search these things on the net also and can get the things, or I will provide some literature, and where you can go and read the different things, or we have the PowerPoint presentation. PowerPoint presentations are cannot be utilized for the writing the answer. So you need some solid things where you can read and can write down the answer to the questions. So I will provide some literature also on a different topics. Okay, so you can read 3 to 4 different, say for on one topic, you can read 3 to 4 different pages and can prepare your own notes or can understand the topic.
Okay, sir. Thank you. It is around to, okay, only 5 minutes are left. It will be difficult to, I want to show you the some facilities of this Microsoft Team, how to write assignment, how to submit it. In next lecture, we will see the things, how to write the assignments, okay, and how to submit it, and how it will be the, it looks when you submit the things. Okay. If someone is using maximum of you may be using the mobile